Hi, and welcome to the Worldwide Center of Math's Problem of the Week. This week, we have a problem for you that has to do with a couple polynomials. So the problem is, suppose a, b, and c are integers such that the greatest common divisor of x squared plus ax plus b and x squared plus bx plus c is x plus 1. And this is in the set of polynomials in x that have integer coefficients, just to clarify. And then the least common multiple of x squared plus ax plus b and x squared plus bx plus c is x cubed minus 4x squared plus x plus 6. So then the problem asks you to find a plus b plus c, so we're going to be looking for what those variables are equal to. So to begin, since we know that x plus 1 is the greatest common divisor of both of the polynomials, what we can do is factor them since they're both polynomials of degree 2. So we can factor them, and to find what the second factor is, what we can do is just look at b is the whole coefficient in this polynomial, and since the original factor is x plus 1, we know that it has to be x plus b. And similarly, for the second polynomial, c is the whole coefficient, therefore it has to be x plus c. So from here, what we can do is we can write an equation from this first polynomial for what a equals using what we have as factors. So if we were to multiply this out, what we would see is that a is actually equal to b plus 1. And we can do the same thing then for this next polynomial, except we'll be writing an equation for what b equals. So once again, multiplying this out, we would see that b is equal to c plus 1. So now we have two little equations, and what we can do is write one single equation for what a is equal to, combining these two. So what we have is that a is equal to b plus 1, which is equal to c plus 2. So now let's look at the least common multiple of these two polynomials. So we know that the least common multiple is x cubed minus 4x squared plus x plus 6. And we can do kind of a similar thing knowing that these are the factors of each polynomial. So what we can do is we can write out an equation using the factors that we already know for what the least common multiple is. So using the factors, we can write out that x plus 1 times x plus b times x plus c is actually equal to what the least common multiple is. And since we already know from this equation over here and this one that there's an equation to equate b and c, what we can do is we can actually substitute in an equation for b, which would just be that c is equal to b plus 1. So now we have a full equation for what the least common multiple is equal to, and we just have one single variable b. So we can multiply this out and then solve for what b equals to. So what I've done is I've just multiplied out x plus 1 times x plus b. Now we're going to multiply that by x plus b minus 1. So multiplying these two out, what we end up getting is this very long polynomial term. And so what we're going to do is just group together like terms to get it into a form similar to x cubed minus 4x squared plus x plus 6. So that way we can solve for what b is equal to. So grouping together like terms, what we get is that x cubed plus 2bx squared plus b squared plus b minus 1 times x plus b squared minus b is equal to x cubed minus 4x squared plus x plus 6. So what we can do now is then just compare the coefficients on the x squared term, the x term, and the whole number term. So looking here, we have that 2b is equal to -4. So obviously b then has to be equal to -2. And if you plug in -2 for each of the consecutive terms, you'll notice that that rings true for all of them. Plugging in -2 here, we end up with 1, so 1x. Plugging in -2 here, we end up with 6. So now that we have the what b equals, we can now plug into these original small equations that we wrote for b, c, and a, and we can solve for what a and c equal. So plugging in, what we get is that b is equal to -2, a is equal to -1, and c is equal to -3. So a plus b plus c is equal to -1 plus -2 plus -3, which is equal to -6. So that's all we have for you today for the problem of the week. I hope you enjoyed watching this video. Check out some more of our playlists on YouTube, look at us on Facebook, and follow us on Twitter.